Alright, hello everybody. Now that we went over trig derivatives, power rule, product rule, quotient rule, we can start chaining these things together. And what's the chain rule? Which means we'll probably have a chain of derivatives. So just starting off with a textbook definition. So say that y equals f of u, it's differentiable at u equals g of x, and u equals g of x is differentiable at x. Then you have this composite function, y equals f of g of x, will be differentiable at x. So basically, this is just how to do the chain rule. And there's two methods. So method 1, I like to call the u sub method. It's kind of like a change of variable, I guess. It's basically just a textbook definition would be dy over d of u. Sorry, dy over d of x equals d of y over d of u times d of u over d of x. And then the second method, derivative in terms of x of the composite function is the derivative of the outside function times the derivative of the inside function. That's the best way to simplify it. So you see f is the outside function, so you take derivative of the outside, and then you get the derivative of the inside multiplied by each other. So we'll start with something easy, a chain rule of the power rule. So we're going to start with we'll start with method 1. This is the u sub. I like to call it the u sub method. So we have y equals quantity of 6x plus 1 to the 4th. So we want to switch it from x's to u's. So we're going to call this the u part. So u is 6x plus 1. Derivative of that, it's easy now, we know that would be 6. Alright, so let's plug in this u here. So we can say y equals u to the 4th. So we would know how to solve that. We would say y prime, power rule, so 4 u to the 4 minus 1, which is 3, times the derivative of our variable u. Now we can just plug everything in. We get the derivative is equal to 4 times the quantity of 6x plus 1 to the 3rd times 6, which would be 24 times the quantity of 6x plus 1 to the 3rd. Now let's try method 2. Depending on the problem, it could be quicker doing it one way or the other. So method 2 is just derivative of the outside and then derivative of the inside, multiplying them. So same thing. We have y equals the quantity of 6x plus 1 to the 4th. So we want to make note that the outside function is the power. So the power is the outermost function. So with that, y prime would be, so we'd do the power rule first, 4 times the quantity 6x plus 1 to the 3rd. And then we use this and then multiply it by the derivative of the inside, which equals 6. So we see here it matches up. The derivative is 24 times the quantity of 6x plus 1 to the 3rd. So method 2 in this case was a little easier, but method 1 could kind of help you start to understand how to use method 2. So that's a power one. Let's move on to trigonometry. going to go trig example. So we'll start off with y equals sine to the 5th x. That, just so for reference, is the same as the quantity of sine x to the power of 5. So using the u sub method, we'd say u equals sine of x. From our last video, we know that the derivative of that would be cosine x. Plugging it in, y equals u to the 5th, and then the derivative would be power rule 5, u to the 5 minus 1, which is 4, du. Plugging it in, 5 times the quantity u is sine of x, so I can say sine 4 to the x, or sine x parentheses 4 times du, which is cosine x. Using the inner, I guess I call it the inner and outer rule, rewrite the problem, y equals sine to the 5th x, y prime, so here I guess the power of sine x to the 5th, say this is the first one, the outer function, so I would get 5 times sine to the 4th x times the derivative of the inside function, which is sine, which is cosine x, and we see that these match up. So either way, if you're good at both or want to learn both, you can double check your work on an exam or on homework. Moving on to another trig problem. Instead of the sine being to the power of 5, we're going to say y equals sine x to the 5th. So we can call u to the 5th, I'm going to call u equals x to the 5th. So du would be 5x to the 4th. Okay, so I'm going to say y equals sine of u, y prime equals cosine of u times du. Plugging it in, y prime equals cosine of x to the 5th times 5x to the 4th. Let's say y prime equals 5x to the 4th times cosine x to the 5th. Same method, or different method now, same problem. Y equals sine x to the 5th. Y prime equals cosine x to the 5th times 5x to the 4th, taking the derivative of that inside, and we see they match up again. Can rewrite it. There you go, and we'll go 2 more problems now for power. So just wanted to go over, and everyone over this. If I get y equals the square root of x, we should know that's the same as x to the 1/2. So fractional powers, you can do the same thing with power rule. So we say y equals, bring down the power, 1/2, x to the negative 1/2. Just a really quick thing if we haven't done that yet. So let's do something with chain rule with our square roots. Y equals the square root 3x squared plus 2. We're going to rewrite it. Y equals 3x squared plus 2 to the 1/2. Start with u sub. So u would be our inside function, 3x squared plus 2. Du would be 6x. So I'd say y equals u to the 1/2 again. And we would know how to solve that, just like right up there. Y prime would be 1/2 u to the negative 1/2 times du, which would be 1/2. U we said was 3x squared plus 2 to the negative 1/2 now, times 6x, times 6x, and then that would be y prime equals 6 divided by 2 is 3x times the quantity of 3x squared plus 2 to the negative 1/2. That's good enough. You can bring that to the bottom if you wanted. And if you try to solve this the inner and outer way, go in red again. Y equals 3x squared plus 2 to the 1/2. I get y prime equals 1/2 times the quantity of the inside. Drop the power by 1 times the derivative of the inside, which would be 6x. We see that matches up again. Y prime equals 3x times the quantity of the inside to the negative 1/2. So that's all great. Let's say we have power and we might have to use the quotient rule. So maybe we're going to have to do 2 substitutions. So this one I only solved in the u sub terms because I think it's the best way to do it. If your mind can think of the other one, that's great. It's definitely possible, but I prefer this way. So I'm going to call it f of x. We got 7x squared plus 3 in the numerator. Denominator is 5x plus 1. And that's going to be to the third. So we're doing the u sub method. So I'm going to call this entire inside y. So y equals the inside, 7x squared plus 3 over 5x plus 1. So we know this is something that we can solve because that would be our quotient rule. So now we have the problem f of x equals y to the third. If we were to derive this, we'd know f prime of x equals 3y squared times the derivative of y. So we have y, we need to find the derivative of y. That would be kind of a review. So say u is 7x squared plus 3. Du would be 14x. V would be the denominator, 5x plus 1. The derivative is 5. Just as a reminder, the quotient rule is the numerator u prime v minus uv prime over v squared. Oh, and I'll even switch this du to u prime, just getting used to that. So plugging things in, 14x times v, 5x plus 1, minus u, 7x squared plus 3 times 5 over v squared, 5x plus 1 squared. So that we can even simplify. So this is what y prime is. Y prime will simplify to, so this is going to be 70x squared plus 14x minus this quantity of 7 times 5 is 35x squared plus 15 over the same denominator. Simplify it one more time. Y prime equals 70x squared minus 35x squared is 35x squared plus 14x minus 15 over the same denominator, 5x plus 1 in parentheses squared. So now that I have my y prime, I have my y, I'm going to use those right here. Just so we know, dy and y prime is the same thing. It means the derivative. Zoom out a little bit. So f prime of x would be 3 times the quantity of y, 7x squared plus 3, over 5x plus 1. That's squared, times my big derivative here, 35x squared plus 14x minus 15 over 5x plus 1 squared. Let's see, we got our so maybe just so we can show, just looking again, I got my 3 here. It's my 3. Here's my y. There it is. 7x squared plus 3 over that. And then here's my derivative. So we took this kind of complicated problem, did all the hard labor in the quotient rule, and got our answer with the U sub method. And it looks fairly simple this way. So we just got to take our complicated problems and nestle it down. Thank you. Have a good day.